section 5.2. We're looking at congruent polygons. So in this chapter we start going over polygons and explaining how they're congruent. As we go further along, our goal is going to be to shorten how we show that triangles are congruent. So a congruent figure is a shape where all corresponding parts are congruent. So all basically angles and sides for our polygons. Corresponding parts are the parts with the same relative position in the two figures. We need to watch how we explain that. Like C, we would say, is the top, but this triangle is turned, right? It's rotated. So H would match up with C. So sometimes you need to pay attention to how it's turned to do that. A lot of times you're using the markings to do that and figure that out. So example 1 says, write a congruent statement for the triangle and identify all parts of the congruent identify all pairs of congruent corresponding parts. So we start with listing our sides and angles. The sides, we want to try matching those up so the right parts are matching up. So when I look at AB, A is the 90 degrees. That matches with FG. So I want to have the F first because that shows where the 90 degrees is. Right? When I look at BC, which is our hypotenuse, right? B has the 1 mark, C has the 2. When I'm over here, G has 1 mark, H has 2. So that would match with GH. Then when I look at CA, coming down, right? A we already said matches with F. C we already said matches with H. So then that would be HF. Right? And these should all have bars over them to show that they're line segments. Okay, congruent angles. Remember, naming angles. In this case, I'm good just using one letter. If you had more than one angle at a side, you need to name it with 3 letters. So keep that in mind as you're going through, right? And I can basically just look at what we matched up above. Angle A is congruent to angle F. Angle B is congruent to angle G. And angle C is congruent to angle H. And our congruent statement does that same thing just with the shape. So when we name a triangle, so for example, triangle ABC, then I want to match it up so the things I already matched up here still match up. So when I look at my congruent statement, I should be able to say that A and F match up, B and G match up, C and H match up. If you're not given anything, the first one you can just name however you want. It's the second one you need to make sure you're matching up. If you're given the first one, then you need to think about how you're matching that up. Example 2 said identify all pairs of congruent corresponding parts, then write another congruent statement for the figure. So they give me one here. So another one is just going to basically be in a different order, but having the same things matching up. So we can either look at the picture and how it's marked, or look here. So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. And then sides, okay, I can look at like AB would match with DE. DE. I can look at the picture there. I can look at how I match them up here, or I can look at this statement. AB and DE match up. BC and EF match up. Right. And then the new congruent statement, I'm just going to go around one of my triangles a different way. So here we'll go around CAB. right? So C matches with F, A matches with D, and B matches with E. So triangle CAB is congruent to triangle FDE. In example 3, okay, they're asking us to find the values of X and Y. So they give me a congruent statement here. QRST is congruent to WXYZ. So I can use that to figure out how things match up. So for example, WX, they give me as Y minus X. Well, WX matches with QR, which is 6 inches. So I know Y minus X equals 6. Not super helpful because I have a Y and an X. But if I look elsewhere in here, I have 5X plus 5. That's W. Right? W matches with Q. So 5X plus 5 is equal to 65. And now I can solve that problem. Subtract 5 from both sides. 5X equals 60. So X is 12. Plug that 12 in here. Y minus 12 equals 6. So Y equals 18. And you watch your lowercase capital letters. This is a bad way to set up this problem. We have a capital X and Y here. We have a lowercase here. We're looking for the variables. So we're not looking. We don't care what these two are, though we should be able to find them based on what they give us. Then we have the third angles theorem. The third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. We know our triangles add up to 180. So if A is congruent to D and B is congruent to E, then C has to be congruent to F. Because whatever these two are the same thing. So when I add them up and subtract from 180, I'm only getting one number. That's going to be what goes in C and F. So that's what the third angles theorem is saying. Flipping that over, right, solving some problems at the top. So example 4 says find the measure of angle V. Right, so V I have up here. If I notice the T and W marked congruent, and U, these angles are vertical angles here. So V and S have to be congruent based on our third angles theorem. So I'm going to do 44 plus 66, which gives me 110. And then our triangle, TUS, has to add up to 180. So 180 minus 110 is 70 degrees. So that is my answer for angle V. Watch when you're doing that how they match things up. When we look at example 5, right, A and D match up. Right, B and C match up. So give me B is 71, so C is 71. The angle CED is 47, so angle AEB is 47. So same concept as what we just looked at, 71 plus 47. They're in different triangles, but I know they're congruent. So I can do this. So I have 118. 180 minus 118 gives me 62 as the measure of angle D. Then we throw in 3 properties we've already looked at. Right? The only difference is now we're talking about triangle congruence. So reflexive property, if you go back, I think that was chapter 3, maybe chapter 2. Reflexive property says something is the same as itself. So for any triangle ABC is congruent to triangle ABC. So any triangle is congruent to itself. Symmetric property says I can flip where they are on the equals or congruent side. So if ABC is congruent to DEF, then triangle DEF is congruent to triangle ABC. And transitive property lets me say that if the first and second are equal and the second and third are equal, then the first and third are equal. I'm going to write this one underneath. So triangle ABC is congruent to triangle DEF. Triangle DEF is congruent to triangle JKL. So triangle ABC, triangle JKL. And then, last thing in our notes, we have our proof. All right. So remember, we start off our proof with our given. All right. They give us a lot of given here because, and this sort of leads into what we're going to be doing in 5.3. The reason they give me so much stuff here is I need to show every single thing is congruent to show my triangles are congruent. What we're going to start looking at is shortcuts. So I can say, all right, I don't need all this stuff. I only need so much. So instead of writing this all out, we're going to circle this. Say all of this is going right here. Right? Then 2. So if I look at what I marked based on this, I marked AD congruent to CB. I marked DC congruent to BA. We marked ACD, right? So ACD is this angle, congruent to CAB. CAB is this angle. They're alternate interior, by the way. And then CAD is this one, with ACB is this one. Okay. So I have most of the triangle marked, but I'm missing a couple things. One thing that I'm missing is this middle line. The middle line is the easy, when all two triangles are connected, that's the easiest thing to mark. AC is congruent to AC. That's my reflexive property. Okay. We will use that a lot as we do things with triangles. So then I have this one based on number 2. Then the only thing I'm missing is angle D and B. Okay. And this one we'll actually only really use in this section because as we start getting to the shortcuts, we're not going to need a third angle. All right? But this is our third angles theorem, right, which we just went over on the other side. So now I have everything marked. So I can say triangle ACD is congruent to triangle CAB. All right, by definition of congruent triangles. And we will be looking at these a lot as we show triangles congruent. It's a good idea as you're doing things to mark them down. It makes it a lot easier to see what we're doing. That is the end of our congruent figures and section 5.2.